Now we're going to have quite a bit of fun, and we're going to use the definition to find a tangent line. So let's start with a line. Find the slope of the graph f of x is equal to 2x minus 3 at the point 2, 1. Now this right here is our point C, all right? So C is equal to 2. Now the first thing I like to do is write the actual definition. I want the slope, and this is the limit, as delta x goes to 0 of f of c plus delta x minus f of c divided by delta x. The equation tells me everything I need to be able to find. Now I'm going to do it very painfully slowly on this problem. You can do this all in one step. What is f evaluated at c plus delta x? All right, this is 2 times. Now everywhere I have an x in this equation, I'm going to put c plus delta x. So this is c plus delta x minus 3. And I'm going to leave it that way for right now. Now what is f evaluated at c? Well, everywhere I have an x in this equation, I'm going to put c in there. So this is 2c minus 3. So now I'm ready to go plug all of this into my formula. M is equal to the limit as delta x approaches 0 of f of c plus delta x is 2 times c plus delta x parentheses minus 3. Now I'm going to put brackets around here because I need to make sure we understand that that's the first term minus the second term. And so this is 2c minus 3, all divided by delta x. Now I'm going to multiply some stuff out. So this is the limit as delta x approaches 0 of 2c plus 2 delta x minus 3 minus 2c plus 3 all over delta x. So now I'm going to simplify. 2c's go away, my 3's go away. Oh, nice. Oh, I don't know what that is. So this becomes the limit as delta x approaches 0 of 2 delta x divided by delta x, or 2. So the slope of this line right here at this point, 2, 1, is 2. Now, you could have just looked at the equation and said, duh, yeah. But now, what if we want to find the slope of the line tangent to the graph f of x is x squared plus 1 at any point? So let's start by, we're going to do any point. So I'm not going to be as detailed on this one. The limit as delta x approaches 0 of f of x. Oh, I want c, I don't want x. Sorry about that. I'm skipping ahead. So delta x, well, of f of c plus delta x minus f of c all over delta x. Now I'm going to plug in what these are. This is the limit as delta x approaches 0 of f of c plus delta x. Everywhere I have an x in this equation, I'm going to put in c plus delta x. So this is c plus delta x squared plus 1. So that's my first term. Minus c squared plus 1 all over delta x. Okay, so life isn't quite so straightforward here. Next step, I need to multiply all this out. So this is the limit as delta x goes to 0 of c squared plus 2c delta x plus delta x squared plus 1, there's my first term, minus c squared minus 1, I'm distributing that negative sign, all over delta x. Now let's see what, if anything, simplifies. I've got c squared, I've got 1. Now, I can take out 1 delta x here. I want you to be real careful doing that. It's an easy thing to make a mistake. So I'm going to factor delta x out of each term to make it a little bit clearer what I'm doing. So now I can cancel because they're both being multiplied. So this is the limit as delta x approaches 0 of 2c plus delta x, which is 2c. So the slope at any point is equal to 2c. So what if I wanted the slope at the point 0, 1? So at 0, 1, the slope is 2 times 0, or 0. At negative 1, 2, the slope is negative 2. Kind of handy, isn't it?